So these are numerical examples, results. I think somebody is showing time off, so I'll just rush through. So again for this. So this is a third type of multimodal technique, which is based on empirical mode decomposition. This is also available for many other disciplines, but nicely being used for civil engineering problem solution here. So this, yeah. So what is it doing is from the signal, it just do some kind of an optimization and picks every time one mono component signal. That means it will take out every single component every time once it finish converges and optimization. So that way, so it breaks your signal into mono components. It fits some kind of a spline, it takes away the average, and then removes that average, and it does recursive way. At last, it gives you a intrinsic mode function. If you take the FFT of it, you will be able to see only one peak in time. That is a monocomponent signal. So once you break that signal into monocomponents, then you have an automated way of identifying which component is damage enriched. So take that only, then work on for damage location and similarity. So these are the capabilities of these algorithms. So that means detection of a time instant of damage is also possible. Location is also possible. It can handle the environmental variability and measurement noise. As per the tests have been conducted, we are able to see it. Then deterioration, the type of deterioration, of course, we are not, we do not know what has caused that kind of a damage, but these kind of damages were tested through these benchmark problems, and we have seen that these kind of damages can be identified. The locations and presence are identified. So types of structures tested were bridges and frame structures. Responses used were acceleration and also the combination of acceleration and strain data. It can be operated as baseline free. Of course, I was not presenting that thing here, but some kind of tuning was done in this aspect also. And it is very feasible for online monitoring as we are not depending on the model of the structure. And there is one small thing which I can show that how the environmental variability is being handled. So there is a technique, nice technique called co-integration. We try to record the responses from the structure for an year or so. So the idea is to cover all the possible environmental effects throughout the year, which a structure can experience. And then we try to bring a linear combination of those. Means these environmental effects can be treated something like it can be repetitive the next year also. So based on that assumption, we just create a kind of a linear combination. So there is a vector which is having a linear combination of all the different environmental effects throughout the year. So that vector, if you are projecting it on a new data, then it will take away the kind of the environmental effect which is available in this and give you only the pure data. So that's how this works. I can't go much now inside. And as a that was for the direct SHM, where the sensors have been installed on the structure and the signals are obtained from the structure itself. This is the indirect SHM where it is for bridges, especially because it uses the vehicle bridge interaction equations to solve the dynamic, the basic dynamic equations need to be solved using BBI. So here the vehicle is being instrumented, not the structure. So identifying the model properties and also damage is very challenging in this, as as we don't have direct contact with the structure. So the vehicle is moving, and many factors are influencing in this, like speed of a vehicle, the roughness of the road, and also the dynamic properties of the vehicle itself. So what will be the sensitivity that how much can be observed? All those things are very challenging. So here we have just employed one variational mode decomposition technique. I'm not again going much deep into it. I can see that people are asking me to complete. So just to highlight, so the vehicle is modeled as a 2 degree of freedom system, having one translation and one rotation. So with that, using the vehicle bridge interaction equations, we just get the responses at the contact point of the bridge and the vehicle. So that contact point response is being processed to get when the vehicle is moving throughout, it gives you one single time series, which is like it is each and every contact point throughout the structure we are obtaining. So from that, we try to get the mode shape. So this is another decomposition technique. It is also giving something like IMF, and we take that and see the energy content of it. Yeah. So this, if you see, these are the frequencies, and these are the IMFs from the BMD, and energy calculation of these IMFs are giving you the mode shapes. So we are able to achieve some 4 mode shapes, and even 5th. It is being done with very much trial, and then many tunings have been done. So far 4 modes are being successfully extracted from this. So with this, I complete my talk. So both direct and indirect SHM techniques have been presented. So especially through direct SHM, I was concentrating on how to identify, how to separate out the damage information from the effects of environmental variability and noise. These are some of the references. Thank you.
Thank you, ma'am. If anyone is having any questions, they can carry out those question answer session during our dinner meet. So now I would like to request our next author, Ansaf Muhammad Ashraf, Rohan Devsurya Devan. Are they from here? Yes. Nitin R. Sudesh Kumar CP from Department of Mechanical Engineering, Government College of Engineering, Kanpur, Kerala. They'll be presenting their paper on design and fabrication of personal noise enclosure for a stone crushing unit. Show me some. Invest.
Now we can try to close the first. There's a big gap. Gap. Yeah. We just status quo.
We're leaving after the presentation. Sorry.
Okay, good evening all. My name is Shamim Badhan. I'm working as an assistant professor in Mechanical Engineering Department, Father C. Rodriguez Institute of Technology. Today, I'm going to present experimental and simulation study of the transmissibility of isolation material. Okay, vibration, it is a phenomenon of the to and fro motion of an element about its mean position. In some cases, vibration is desirable or undesirable. It depends on application. Okay. In some cases, if it is undesirable, we need to isolate the machine component or devices from this source of vibration. So for that purpose, isolation materials are used. The isolation materials are basically characterized with the help of the characteristic transmissibility. So in the present study, we have determined the transmissibility of isolation material with the help of simulation study and experimental study. For that purpose, we have built an experimental setup in our laboratory. Figure shows the experimental setup. It consists of a motor. Here we have used DC motor so that we can vary the load on the isolation material. We have used two C channels made up of mild steel, which are available easily in the market. And in between these two C channels, we have put isolation material. Here we have tested two types of material, one rubber, another one coal. Okay, hardware for the component. Here for the measurement of the force transmissibility, we have used strain gauges. We have mounted the strain gauges on the wall of C channel. And for that purpose, we need bridge completion. So bridge completion is carried out with the help of load cell amplifier. Here we have used DC motor. So we need a DC driver which can vary the speed of the motor. And we have attached one disc. On that disc, we are attaching the different weights so that we can vary the force input to the isolation material. Okay, so these are the component, motor, bearing and strain gauges. So in that case, bearing, we have used a vertical structure and that easily can slide along with those columns. So we have used this bearing for that purpose. So as now we have used three plates, one plate at the bottom, another plate above the first C section, and in between these two plates, one isolation material, and again one more C section will be there. And top of the all this, we have placed the motor. So remaining thing will be explained by the Mahesh Chari.
So good evening all, and I will be presenting further. So as Shamim ma'am already told that we are changing mass and the angular velocity of that disk using motor. So if we go on to this slide, so as you can see on the top we have motor, and you can see that there is a disk and one aluminum mass is present on that. So what we did, we varied two things. One is angular velocity and one is the mass. So by changing both of the things, we get different set of forces which we applied, and we tested our two vibration isolator materials. So you will see in that the 6 number. So that pink material is vibration isolation material. So at that position, we will change rubber and we will put quartz to check its value. So sorry. So the excitation force we get from mr omega square, and this force we can either measure by using RPM of that disc, or we can use strain gauges which are present at the web of that C section. So that strain gauges as a unit are not useful if we don't connect it to half bridge strain gauge circuit. So here we use half bridge as it provides better temperature compensation, and it will provide more sensitivity over to quarter bridge strain gauge circuit. So what we did is we attached, we completed this whole setup, and then we tried to calibrate it. And when we so strain gauge works on the principle that when we apply force onto the strain gauge, the conducting material changes its shape and size. So when we suppose apply tensile load to it, the length will change, area will decrease, and vice versa. If we reduce when we provide compression, then length will decrease, area will increase, and that resistivity of this conducting material is directly proportional to length and length by area. So when we apply our force onto our model, at that time the this Wheatstone bridge gets unbalanced, and we will get some VL. As you can see that at the center we have voltmeter there. So when we apply some force, that time due to unbalancing bridge, we will get some voltage there. So what we did is we first calibrated that. So we applied a known force to that, so that we will get a change in voltage, and then we plotted that graph you can see on the right. So we plotted that graph, and we tried to match the line from that point, because experimentally it is not possible to produce that vertical line. So that was all experimental part, and then we tried to match that values with simulation part. So in simulation we used a student version of Autodesk Inventor, which works on Nastran. So what we did is we first did simulation for the C sections to check where will we get the maximum strain, and that we can utilize in to position our strain gauges onto our model. So in the first left section, you can see that where on the wave of C section we are getting the maximum strain. So what we did is we put our strain gauge circuit onto this wave on both sides, and the other side, the other purpose of simulation was to check which orientation of C section will provide more strain, so as to get more accurate results. Because if the strain is very less, it is very difficult to measure, and then we will have more error in our transmissibility values. Then and the third purpose is we directly created model in Inventor, and we provided that rubber material into between, and then we from external we provided that material values of rubber there, and then we applied forces. So what we checked is at the, you can see that in C section we will get different set of stresses. Then at the from that stress value, because we know the area of that section, we can get difference in forces there. So in the top we will get one force, and in the bottom C section we will get different set of forces. So the transmissibility will be measured as Ft by Fo. So Ft is the force transmitted at the bottom, and Fo is applied force. So in experimental and in simulation study, both we measured Ft and Fo. So in experimentation, we get Fo directly from mr omega square, and Ft we measure from strain gauge circuit. So that using this we got experimentation transmissibility values, and as I earlier explained how we got simulation values using stress value. So you can see that experimental results for rubber. So force applied you can see in the first column, Fo 4.82, and the transmitted force was very less, 0.53. So the transmissibility comes out to 0.11. So changing the radius and mass and speed, we get a different set of forces and for rubber and for cork. So you can see that the transmissibility values for rubber is around 0.2. So if you take average, it will come around 0.2, and for cork it will come around 0.4. And this is conclusion in simulation and experimental studies. So in simulation results, you can see that transmissibility is 0.186 and 0.11. So there is a small approximation in in experimental studies, because we cannot trace every various force transmitting. We cannot account for friction wherever which is neglected in simulation result. So that's why it is very difficult to match experimental results and simulation result exactly, but we are getting values near around each other. So though we can see that transmissibility of rubber is 0.11 and the cork is 0.53. So rubber is, as we all know, that rubber will transmit less force. So so that's all. Thank you.
Thank you, sir. Thank you, Shamima. Now I would request Dr. Nilesh Deshmukh, sir, to award token of appreciation for our paper presenters. First, I would like to invite Lakshmi ma'am. She is not present right now. I would like to invite Shamim. Thank you, sir. I request our session chair to summarize the session and address the paper presenters. Dr. Srinivas, okay. Okay, Lakshmi. I request Nilesh Deshmukh, sir. Okay, Gambhir, Dr. Gambhir. Please award token of appreciation to Lakshmi ma'am.
Yeah.
I request Dr. Srinivas Hoku to summarize the session.
Thank you. Thank you to you. So, it's a long day for us, outside the day. So, for that, I think this session we got the presentation one by Dr. Lakshmi. Yes, presented on different algorithms and techniques for diabetic detection using quadratic measurement. So, unfortunately, it's a good research topic actually for the students and the medical students. I think it can be very helpful. Even it is not only for the civil engineers, but even for the mechanical component, mechanical structures also, those types of techniques can be used. And other than by Shami Patan and Mahindra, the presented on transmissibility of a material. So they use two different types of materials and try to come up with how the transmissibility can be happen. And what is the effect of these materials, the efficiency of these materials. So these were the different presentations, and I wish all the best to the others. Thank you.
Thank you, sir. I hope everyone has put their lucky draws in the drop box, and we'll be having a quiz session quickly, very quickly actually. So I asked Dr. Sanjay Rukande to conduct the quiz activity. So we'll be having 2 coupons.
I won't take
for
much
lucky
time. I will start soon. So these questions are taken from the author. will ask these questions. If anyone able to answer other than the author, then prize will be given. So first question, yeah. What is the fault frequency in case of the journal bearing groove defect? What is the fault frequency in case of a journal bearing groove defect? If anyone knows the answer, please raise the hand. Other than Pallavi, yes, yes, sir. 6x is right answer. 6x of operating speed. Then second question from the same is who is the first person to give satisfactory mathematical model for the vibration of plate? Who is the first person to give satisfactory mathematical model for the vibration of plate? Now it's Sophie German in 1850. So coupon can be given to that, sir.
So kindly tell your name.
Santosh. So give hand, big hand for this.
Thank you, sir.
Okay, there is one more coupon, so we will ask one more question. Other than Professor Shamim Pathan, will answer. Why half bridge circuit is preferred for the quarter bridge circuit? Yeah, one is temperature compensation. Another reason, one more reason. Yeah, it provides higher bridge sensitivity also. So coupon can be given to sir. Sir, give correct answer. So, yeah, thank you very much. So we will end our session here. Thank you.
So there are 3 more coupons which will be held from lucky draw, that will be done tomorrow morning. So thank you everyone. I would like to once again inform all our delegates about the gala dinner and cocktail from 7 to 10 p.m. at Ramada Hotel, Millennium Business Park in Mahape. We have arranged the bus for transport. It is standing right in front of cafeteria. And so today I conclude the day 1 sessions and will commence day 2 sessions tomorrow at 9:15 a.m. after breakfast, which will be from 9 a.m. to 9:15 a.m. at Canteen in Annual School of Law. Thank you.
Thank you.